Yeah, so I'll talk about one of the aspects of the blockchain space that I find the most fascinating, which is just the way that it creates an open field for experimentation and just the kinds of really interesting and unique things in economics, in governance design, in uh, other fields that people are actually doing with blockchains, and even things that we've learned from some of the experiments on Ethereum as well as on other systems kind of very quickly in the last few years. And then potentially just see what other kinds of things could be tried on blockchains in the future, and how some of this might like end up sort of feeding back so that we can have better mechanisms in general. So what's interesting about blockchains, right? So blockchains have a wide open room for experimentation in economics and finance. So blockchains kind of do for like everything that involves money what the internet did for everything that doesn't involve money, I guess. So blockchains make it just very easy to try out all sorts of mechanisms of different kinds. You can even automate the logic with smart contracts. You It's very easy to accept payments in cryptocurrency. It's very easy to send payments in cryptocurrency. Um, it's very easy to just have all sorts of applications and all sorts of designs. You don't even need to trust anyone to hold the money, which is, I think, a serious and really important improvement that allows these things to be to scale to much larger amounts of value than you would be able to if they were centralized systems. And no, we actually see many different kinds of things being tried by different people in ecosystems like Ethereum. So, I mean, a big one for, I guess, fans of Hayek in particular is the concept of currency competition, and can you have currencies that have different monetary policies and they can compete with each other on an open market, and you can see which ones actually end up kind of winning out in practice, right? And like there are many different kinds of cryptocurrencies within the blockchain space, right? It's definitely not just Bitcoin, right? There's different kinds of fixed supply assets. There's assets that are almost fixed supply. There's algorithmic stablecoins, DAI, RAI, Liquidity, lots of other ones. Then there's asset-backed coins. There's assets that target other kinds of indices. There's assets that have like issue new coins under certain conditions, that burn coins under certain conditions. So there's a lot of different kind of monetary policies that are being tried, and we can actually get to see like what the results of these kind of happening in real markets are. Are people willing to use them? Do they actually break under conditions of extreme stress? Are there other challenges with them? And I feel like we've actually learned a lot about like different kinds of just currency models being tried out in the blockchain space. Governance designs. So once you make a system that kind of passes a certain level of sophistication, whether it's a blockchain or whether it's a contraption on top of a blockchain, then often enough you're going to need to have some way of agreeing on either new features or changes to the parameters. And so you get just different kinds of governance models. And there's many different styles of governance that you can have, right? So like, for example, for just base layer blockchains, there's off-chain governance, and then there's on-chain governance. On-chain governance meaning that you come to a decision using some mechanism that's written in like code on chain, and whatever the result is, the result just gets implemented automatically. Off chain means that like, well, you have some kind of social coordination gadgets to help people agree on how the rules are going to change, but ultimately users still have to manually download and run the clients that implement what the changed rules are. When you have voting, do you have coin voting? Do you use quadratic voting? Is there some kind of other concept of membership in the DAO or whatever other system you're building, or and so on and so forth? What is the scope of governance? So if you have governance, you don't necessarily want to give that governance unlimited power. Maybe that governance only has the right to set some limited parameters. Maybe that governance only has the right to change things after a 90-day waiting period. Maybe it only has the right to spend money from a treasury and change parameters within a limited range, but it doesn't have the ability to do anything else. These are all things that have been tried. Ways of exchanging between assets. Economics focuses a lot on market design, and there's definitely many different kinds of markets and many different ways of trading some things for other things that are being done on blockchains. So just a huge number of models is being tried in all of these areas and plenty of other areas as well. So what makes Ethereum uniquely powerful, I think, is this concept of smart contracts, right? So Ethereum lets you upload any program onto the blockchain, and the blockchain executes the code that you uploaded every time someone sends a transaction that interacts with your application, right? So when you upload a program on chain, you're creating what's called a smart contract. That smart contract has an address, and when you send a transaction that goes to that address, that transaction automatically triggers the application code. And applications can send what are called internal transactions to each other. So applications can interact with applications just like users can interact with applications. And today we have a large ecosystem of applications, all kinds on top of Ethereum. These applications do frequently interact with each other. People are very excited about this concept of what's called composability, where applications can talk to each other very easily. We actually do see a lot of these things happening, right? People build stable coins, then people build other applications like prediction markets that use those stable coins. People build applications that like points to those assets in all sorts of different ways. So, you have things interacting with other things the same way that they do on the internet, except the benefit of a blockchain is that none of these things that people build have to rely on some kind of central operator in order to keep working, right? So, it's not like a website where if you have a website that like embeds or has a link to another website and then that second company gets bored and then you have a dead link, right? Like on the blockchain, there's some applications that depend on central providers, but there's plenty that don't. And so it's very easy to have these webs of interactions without even needing to worry about like, is one link just unexpectedly going to stop working one day? Because if some people lose interest in an application, then just like other people can come in and replace them. So interesting examples of mechanisms, both within the Ethereum ecosystem and within other blockchain communities that people have experimented with and people have tried. I think algorithmic stablecoins is definitely by far the most sophisticated and interesting. People have spent a lot of time like thinking about monetary policies of coins, and stablecoins are an interesting attempts to solve one of the biggest problems of cryptocurrency, which is the fact that it has a very unstable price. So the way that RAI works, right, as one example, is it's a algorithmic stablecoin. So it's a stablecoin, but there's no central entity that's backing it. There is a smart contract that's backing it, and it's backed by other cryptocurrency, right? It's actually collateralized by Ether, and it's over collateralized by a factor of like about 3. I think the minimum over collateralization is 1.5, but the actual collateralization kind of goes up and down. Usually it's like in the 3 range. And if prices really or basically there's this mechanism that's kind of built on top that actually tries to kind of automatically twist these very simple knobs to make sure that like if the price diverges from what the target is, then it becomes more or less attractive to hold the asset. So the mechanic is pretty simple, right? So you maintain a target price. And so it's called the redemption price. If the actual price is greater than the target price, right, the system is aware of what the actual price is because the system can kind of poke into things like decentralized exchanges that run on chain, like things like Uniswap, for example. And if and then it also has oracles that like get the price of a cryptocurrency is relative to assets that exist in the outside world. So if the actual price is greater than the target price, then the target price starts going down. So you can think of this as, oh, actually, I think I got these mixed up. If the actual price is greater than the target price, then no, right, the target price starts going down, but think of it as being a negative interest rate. So basically, the idea is that the target price starts going down, and so it's like the coin getting a negative interest attached to it in order to discourage people from holding that coin, right? So if the actual price is too high, then you have this mechanism that just discourages people from holding it. It makes it less attractive to hold, and it makes it more attractive to borrow and sell. And so because of that, the target price would start or the actual price would start going back down again. If the actual price is less than the target price, then the target price goes up. And you can think of this as being like a positive interest rate to encourage people to hold the coin and to discourage people from borrowing and selling the coin. So fairly simple mechanism. There's also this kind of mechanism where the peg, so the redemption price, is ultimately enforced by the collateralization mechanic. So for every dollar of RAI, there's about $3 of ETH. And if prices really diverge, right, if asset prices go crazy, then there's this mechanism where if you put in some ETH, you can borrow the RAI, then you can sell the RAI for a very inflated price, and then you just like forget about the ETH that you borrowed and you never pay it back, right? And like this is profitable. So if the price of RAI like really becomes too high, then there also is this incentive where you can just like keep on doing this loop where you borrow the RAI, sell it, it gets some ETH, and then you use the ETH to get more RAI, and then obviously prices will like drop very quickly if this happens. And then if the price of RAI is extremely low, then or if the actual price of a RAI is extremely low, then it just becomes very easy for people to buy a whole bunch of it, right? So there are these mechanics that try to kind of target an equilibrium. And so RAI isn't the only one, right? So like DAI does something like this, except instead of having an automated mechanic, there's a manual mechanic where there's a governance process that triggers changes to the interest rate. But in either case, it's actually been very effective at handling even large changes in the price of ETH, right? Like even sudden drops by like 40 or even 50% that happen within a single day, which is actually pretty amazing. Another experiment, delegated proof of stake governance, right? So this was so blockchains like Bitcoin and Ethereum tends to have fairly minimal and off-chain governance, right? So, and Bitcoin is obviously extremely minimal, right? It just, it has features that are extremely slow. It has a very strong commitment to backwards compatibility. Ethereum has, I think, a commitment to go further in that direction later, but right now it's still in this period of a kind of rapid iteration of the protocol, but it still doesn't like randomly print money and give it to people. It doesn't like interfere with applications. So it stays hands off in the application space. But then there's this third school of governance created by Dan Larimer called delegated proof of stake, which is basically a system where users that have coins inside of the system vote on delegates, and it's either approval voting or it's kind of like a modified approval voting where there's a cap of how many people you can approve, and then the n delegates that have the most coins voting for them run the consensus. So n is usually 21. And these delegates have very strong powers inside the chain, right? Usually. They don't have to, but they usually do. So they can often change protocol rules. They can often freeze accounts. They can forcibly transfer money between accounts often. They can get paid out of a large pool of issuance. So now these abilities, like they're different with different chains. You can have a delegated proof of stake chain that still has fairly minimalist governance, but the dream behind delegated proof of stake, I think, was to be able to like have a blockchain that has this sort of notion of like very activist sovereignty, and where you have this governance that's able to do these very powerful things. But in my opinion, like this ended up, in a lot of people's opinion, this was a failed experiment. Like basically because coin voting just very quickly collapses into extreme plutocracy, it gets captured very easily. And this has happened on multiple occasions, right? I wrote this article on Vitalik.ca, my blog. I think it was called Notes on Blockchain Governance. And then there was another one that's governance Part 2, Plutocracy is Still Bad. And I just talk about like the kinds of failures that we saw. Like basically it just collapsed into this equilibrium where a bunch of rich people in EOS and a bunch of exchanges and a bunch of like delegates, they just made these agreements to vote for each other. And that just ended up completely breaking the economics. They ended up capturing the rewards. And so now like there's these rewards don't really exist anymore. To the or at least they were reduced like really severely. And then in Steam, which also used delegated proof of stake, there was this mechanic where, or there was this incident where Justin Sun, this crazy Tron person, basically bought up a company that had a large number of Steam tokens and then tried colluding with exchanges to kind of consolidate power. And the only way that this situation got resolved is basically the community just like said, okay, we're going to just make a fork that goes outside of the delegated proof of stake process. And in this fork, we're going to just delete the coins of everyone who participated in the attack, which itself is like a really interesting and innovative response, right? So this is like one example of an experiment that like it had a lot of promise, I think, and a lot of people were excited about it. It ended up not going very well. And maybe it works a bit better if you assume the possibility that like if things get too bad, then you can just fork it and you can kind of delete the coins of everyone who contributed to a really bad decision. But like that's not necessarily a perfect solution, right? Because you could still have like medium bad levels of capture in a system. But we'll see. Quadratic funding, another interesting experiment. So I think what's been happening is that over the last few years, the blockchain space has been really recognizing the extreme importance of public goods to the blockchain space and to open source and internet-based ecosystems in general, right? Like on the internet, the average good is a public good, right? Like when I write a blog post, it's a public good. If this video ever gets uploaded and becomes freely available, it'll be a public good. If a person writes a piece of software like a wallet or a client, that's a public good, right? Like it's anything that just benefits a large unselective group of people, where like you can't have fine-grained control where you can kind of like choose who you exclude or include. Like that's a public good, and the internet has lots of those. And funding public goods historically has these massive tragedy of the commons problems. And one of the fascinating things about cryptocurrency is that it gives you these large pools of capital where you can use them to fund public goods. And these pools of capital, like they do not require you to capture an existing coercive monopoly. They do not require you to capture an existing corporate monopoly. You just have a community, and a community has a coin, and that coin just sort of creates this pool of capital out of the ether, and like you can just immediately go and start deploying it for things. But the problem with, or one of the problems with this approach is like, what is the governance, right? Like once you have like this kind of tap, like everyone's going to fight for like, how do you getting control of the tap? And it's very hard to have a like fair mechanism where people can actually agree that it's fair for actually allocating funds that's also resistance to capture. So quadratic funding was this like really interesting idea from Glenn Weil, right? Like basically it's this mechanism for kind of quote theoretically optimally funding public goods. So the idea is that this isn't a mechanism for raising money, it's a mechanism for spending money. So you assume that there is a central matching pool, and you can get the central matching pool. It could be a wealthy donor, it could be a corporation, could be a government, it could be a coin that has issuance, could be a transaction fees in a protocol. It could be lots of things, right? And donations get matched from this central matching pool, but the matching is not linear, right? So the matching is higher for small donations, and it's higher for donations to projects that have lots of other donors. So the idea is that if you donate to a project where you're the only donor, well, that's probably not even a public good at all. That's only something you care about, and so you don't get any matching. But if you donate to something that has like thousands of other donors, then that's obviously a public good, where you're not just benefiting yourself with your donation, you're also benefiting all of these other people who have demonstrated by their own donations that they really care about this project. And then the reason why matching needs to be higher for small donations is basically like it's the same logic as quadratic voting, right? Like the first like $1,000 of money that you direct to a project is going to be very cheap. Like it might cost you $1, but then the second $1,000 of funding you direct will cost you $2. The third $1,000 you direct toward a project will cost you $3. And so every kind of additional increment of like 1,000 or whatever it is dollars that you contribute to a project, like every additional increment costs $1 more than the previous, right? And so the idea is that the number of increments of like contribution to a project that you purchase is like you'll just keep on buying these increments until the next increment it costs you more than you're willing to pay, right? So the number of increments you buy ends up being proportional to the amount that you're actually willing to pay. And so like the amount that you could that the project gets actually is proportional to like how much you care about it. So you get like that really nice correspondence, except you get it for public goods, which is pretty amazing, right? So it cancels out the tragedy of the commons for regular donations. And we actually have used it to fund public goods in the Ethereum ecosystem for about 9 rounds, right? So there's this thing called Gitcoin Grants, and it's been funding Ethereum public goods, and the results actually have been pretty amazing. Uniswap. So this is in a bit of a different sphere. This is designs for exchanging between tokens. So Uniswap is, I think, the problem that it was trying to solve is like, how do you have an exchange, a way of very easily trading between 2 tokens that requires as little infrastructure as possible, that's as maximally decentralized as possible, and that can survive with a very small number of traders, right? So it was inspired by ideas like logarithmic market scoring rules and prediction markets. Basically, you know, that too was trying to solve the same problem, right? Like if you have very few participants, then it's too thin for an order book. And so how do you make sure you can still have a market? So the idea here is that it's this marketplace where you have 2 types of participants. You have traders and liquidity providers. So you have anyone can set up a Uniswap instance for a pair of 2 tokens, and we can call the tokens A and B. And there is a smart contract that holds A tokens and it holds B tokens. And the way that it works is that the Uniswap contract maintains a rule that the quantity of A tokens that it has and the quantity of B tokens that it has remains at some constant, right? So like, for example, let's suppose that at some point in time, the quantity of A tokens and a quantity of B tokens are both equal to 10. So K equals 100. The way that you buy and sell against the system is you just kind of change your position on the curve, right? So we say, let's say you sell your A coins, or you want to get B coins, right? So if you sell 2.5 A coins, then the amount of B coins that you'll get back is 2, right? And why will you get 2? Because when you give the contract at 2.5 extra A coins, then the quantity of A goes up from 10 to 12.5. And then for the constant to stay at 100, then B has to decrease from 10 to 8. And so the difference for going down from 10 to 8 is 2, and the 2 coins go back to you. So the product is still 100. Now, if someone else wants to then sell another 2.5 A coins, then the quantity of A is going to go up from 12.5 to 15. The quantity of B will go down from 8 to 6.67. And so they're only going to get 1.33 B coins, right? So when someone makes a purchase, that also automatically kind of pushes the increases or decreases the price. And so like basically the price also stays in balance as a result of just people arbitrage trading against it. The incentive to put your money in and be part of the pool, there's 2 incentives, right? One is that if you are a participant in this project and you just personally want it to be easy and liquid for people to get in, then you have the incentive to participate in the pool, but also it can be profitable to participate in the pool, right? So there's a small fee, so you actually take 0.3% off of whatever you get out, and then that goes to the liquidity providers, and so K actually ends up increasing over time, right? So it's this really fascinating mechanism. It's theoretically inefficient, right? Because, you know, theoretically it's like, oh, the liquidity providers don't really have much of an ability to like really deeply express their information about the market. They just have like this very dumb, like put money in and get money out mechanic. There's a lot of slippage. If the markets move too much, then liquidity providers can lose. So theoretically, traditional finance people tends to be like, oh, this thing is really horrible. Like obviously order books are superior, but in practice, Uniswap works amazingly well and people just really love it. So that's just one of these sort of fascinating differences between theory and practice. Uniswap is one of the most popular applications on Ethereum. I think for the last week, the transaction fees paid to access to Uniswap have actually been higher, or the transaction fees paid to the fees paid to the liquidity providers have been higher than the total transaction fees paid to use the Bitcoin blockchain. So it's pretty amazing. Token issuance model. So token issuance models are also interesting, right? Because the whole concept of like a blockchain project that has a token is this weird thing where it has some aspects of being like a corporation, but also some aspects of being like an open source project. I think there's more of like an implied spirit that this is supposed to be an open thing that benefits everyone, and you're not supposed to be greedy and try to maximize value for early participants out of it. There's more of a kind of volunteer spirit and like lots of people just like throwing their resources in. And there's this, it's much more transparent. So there's this problem of like if you're launching a new token project, how do you properly balance between rewarding very early contributors, so people who really did a lot of the work at the very beginning, and ideally you want to reward all early contributors, right? So like in a startup, normally, you have big rewards going to a few people, but then there's a lot of other people who did important work that just get nothing, right? Like even people who just did things like participated and provided like just reporting bugs and providing tech support to other users. Like that's an important contribution, but in a traditional startup, it just gets zero reward. It would be nice to be able to just provide all the like reward a broad pool of early contributors. Funding short-term protocol development. So for things where you have to pay people in cash, like you have to get cash, right? You need investment, and how do you like reward people who provide that cash investment? Making the system fair for later users, so you don't want it to be too plutocratic down the line, because you do want to maintain some decentralization. And you just also just wants to have widely distributed ownership. There's a lot of different models for issuing tokens. So you can have like direct pre-mines. You can have a direct pre-mine just says this person gets 0.77%, this person gets 0.46%, this person gets 0.44%, and then you keep going down a list. You can have a token sale, you can sell the tokens, and there's lots of different models for token sales. Airdrops, so just like give the token retroactively for free to people who contributed in some way. Treasuries, so just put the token into a DAO, and the DAO has some mechanism where it gets governed and like some amount automatically gets distributed over time. So other interesting things that are happening. Designs for exchanges other than Uniswap. So there's descending price auctions, is one good one. Frequent batch auctions, a big favorite of economists. Some experiments with that happening on Ethereum. I think recently on Ethereum, gas prices have been fairly high, and Uniswap does an amazing job of being vastly cheaper in terms of gas costs than almost any other one of these systems. So that's a big part of why Uniswap has been so great. But we are working on scaling technology, and so gas costs are going to become cheaper. And when that happens, then I think we are going to see a kind of more interest in these other models as well. Other forms of governance, so governance that's not coin driven, governance that's kind of people driven, governance that's like has some very specific participants. You might even have some notion of like centralized actors that have some power to set parameters and implement features, but don't have unlimited power. So you might have a delay attached. You might have the ability to get voted out. Anti-Sybil mechanisms, so mechanisms for preventing like people from just getting a huge amount of attacks and using that or a huge amount of accounts and using that to attack the system that are not money based. Proof of humanity is this decentralized mechanism that tries to get a kind of one token per person mechanic. Pope, the proof of attendance protocol, you get a token if you participate in some event, and then those tokens eventually get used for airdrops. They get used for like voting. They get used for a whole bunch of things. On-chain auctions for other purposes. So we at the Ethereum Foundation have even experimented with using on-chain auctions for things like tickets to our DEF CON conference. Just mechanism design in proof of stake consensus. And in proof of stake consensus, you have to reward people who participate correctly, penalize people who participate incorrectly, avoid incentivizing centralization. And so there's a lot of interesting experiments happening there. So why is this important, right? So blockchains in general, I think they make it much easier than before to do what I call building your own institution. Now, institution can mean economic incentives, but it could also mean structuring activity in other ways, right? It could also mean structuring activities around social motivations, around other kinds of mechanisms, around like motivations that kind of are intrinsic and that people already have. Just ways of like formalizing the concept of participation in some ecosystem, like some of these, proof of humanity, that's kind of proof of like being a unique human, institutions for just governing different kinds of things, just the concept of forking and experimenting with designs that have different levels of like being easy versus being hard to fork. Blockchains also make it easy to break institutions, right? So attackers are often anonymous. If you make a profit, you can often get away with it, and people are not going to catch you. Sometimes they will, sometimes they won't. So hunting the wolves is not an option. The only option that you have is to armor the sheep. And I actually think this is something that's very good. I think that in general, a lot of cybersecurity, like especially cybersecurity government policy, has been very focused on like hunting the wolves and not really focused on armoring the sheep, right? Like imagine a world where the NSA, instead of hunting and instead of like trying to hack and spy on everyone, instead like just helped make patches to Linux and Android and like just made sure that it's as secure as possible, right? So instead of making foreigners unsafe, it would be making the Americans safe. And then imagine other countries also had intel security agencies that worked in that way. Like if I think doing less hunting wolves and more armoring the sheep could actually lead to kind of a peaceful world and a world that works much better. And like cryptocurrency is nice because it actually forces people to like go into that mindset, right? Like you can't like say, oh, it's the attacker's fault and we're going to go after them because, well, attackers are everywhere. And guess what? Like if there's economic incentives, they're going to come. But you do have a huge number of tools, both cryptographic tools and economic tools, with which you can kind of improve on passive security, and you can create systems that actually just can't survive attacks. Experiments are all transparent, right? So everything that happens on the blockchain is very transparent. It's very easy to analyze. If one person does something, it's very easy for other people to analyze it and to come to their own conclusions around it. And we could get lots of information out of all these experiments, like as I've already talked about, right? So there's a lot of interesting learnings that can come from this stuff. And like quadratic funding, for example, there's already a lot of interest in exporting it to non-blockchain contexts. There's a lot of interest in using DAOs for other kinds of contexts. There's interest potentially in using like even just blockchain cryptographic security technologies, things like multi-sig wallets, things like social recovery wallets for other contexts. So there's a lot of things that kind of the blockchain space can sort of build that can be applied to other places. So some examples of things that I think we've already learned and that the blockchain ecosystem has helped us learn. One is that public goods are really important on the internet, and we should take public goods seriously. If we do not take public goods seriously, then often enough, the thing that wins is not decentralization and freedom. The thing that wins is just centralized alternatives that are optimized for making money. Failure of delegated proof of stake, so how coin voting governance can be really vulnerable to plutocracy and capture. Stablecoin designs, right? So we've seen many algorithmic stablecoin designs that are really bad actually break in real time, right? for every good algorithmic stablecoin, there's like 5 bad algorithmic stablecoins. And for some reason, there's just these Silicon Valley VCs that keep on pumping $120 million into them. I'm like, okay, fine. But at the same time, good algorithmic stablecoin designs don't. And many of them survive massive sudden drops in the price of collateral, right? So for like when the price of ETH dropped by about 40 or 50% over the course of a week, DAI survived totally unscathed, RAI survived totally unscathed. When the price of ETH dropped by 50% over the course of a day about a year ago, DAI survived totally unscathed, right? So I think what we've seen with the algorithmic stablecoin space and Ethereum so far is like a refutation of both voodoo economics. So like, oh, you can make an asset be stable just by saying that the asset will be stable, and we can make an equal, like, something folk theorem. You can make an equilibrium for whatever you want by just saying that that's the equilibrium, and you can kind of meme it into existence. You don't have to like care about economic reality. And then also it's a refutation of the very pessimist perspective that says that maintaining a peg is fundamentally impossible, and like if you even try, eventually you're just going to get attacked and killed, right? Like, no, we've actually seen stablecoins survive events that are incredibly massive, right? Like, in the fiat world, like, when stocks drop by 23% in one day, you call that Black Monday. In the crypto world, when crypto assets drop by 23% in a day, we just call that, Monday, right? And assets, these systems can survive that. Many token sale models proved vulnerable to exploitation. So when people did some token sales back in 2017, one of the things that they did that I thought was like particularly a bad idea was that they tried to use the first come first serve model in an attempt to be fair, right? Like there's a lot of people that kind of think in this way, right? Like they sell whatever it is, like whether it's concert tickets or food or whatever, at prices lower than the market clearing price because like, some desire to be fair to people, some like desire to not be too extractive. But like that always ends up like that sort of strategy ends up being very dangerous, right? Because like you're creating this kind of arbitrage opportunity, and often enough that arbitrage opportunity gets exploited. And on the blockchain, arbitrage opportunities are incredibly easy to exploit, right? Like basically what happened to all these projects is that whenever there's one of these first come first serve ICOs where there is a cap, then just the miners win everything, and people that are better than everyone else at sending transactions with really high fees win everything, right? And so the interesting thing with the blockchain space, though, is that I think like first come first serve is pretty dumb, but if you value being egalitarian, which is a totally reasonable thing to value, there's actually better ways to achieve fairness, right? Like for example, you can make a design where you kind of plug it into like say proof of humanity or like the proof of attendance protocol, and like the first $500 worth of a token that you buy is 50% off, and then above 500 like you would have to pay a higher price, right? Like that's one example of a mechanic that's fair, that's harder to exploit, and like that actually kind of uses the different aspects of a blockchain and sticks them together and does a really good job of it. Quadratic funding takes time to work well, right? So you need not just the mechanism, but you also need the culture around the mechanism. This is one of our interesting learnings, right? I think one of the fascinating things even about traditional markets, right, is like how much of the efficiency of a traditional market is fundamentally very social in nature. Right, like for example, if you go to a Starbucks and like you're paying, $3.55 for a tea or whatever it is that they charge now, you like how do you even know that $3.55 is a better price to pay for a tea? Like, are you personally doing like some kind of like expected utility calculation of, oh, this will make my life experience 3% better for 45 minutes and my salary is $80,000, and I'm going to do some division in my head and verify that it's okay? Like most people don't do that, right? But the reason why these markets still end up working actually surprisingly well in practice is because they come in the context of like this established culture of people doing things, right? Like first, if you go to a Starbucks and you see a tea for $3.55, you know that a bunch of other people have, like the Starbucks exists, and so it's clearly able to maintain a profitable business model using this model. And so some people clearly finds the trade reasonable. there might be people in front of you in line. They find the trade reasonable. You have a history of yourself participating in this mechanism before, and like what getting a T is like, what not getting a T is like, right? Like there's all of these different signals, and these signals like they depend on lots of people participating. They depend on you having these experiences over time. Like if some Martian like just like pops down to Earth and it just said like, hey, would you like some Martian candy that gives you some weird sensory experience you've never heard of before, and it costs you $74? Like, you have no idea whether or not that's a good trade, right? And so it does take time, and it does take all of this sort of second layer behavior involving a kind of passive interaction of people observing each other. And quadratic funding is the same, right? Like with quadratic funding, like by default, it's like, oh, I can give $5 in order to make sure that this public good gets an extra $520. Is that valuable? Do I care about that? Would I rather give my money somewhere else? How does this even work? But then over time, as you have these rounds of funding take place, the efficiency of the mechanisms improves, right? Like people get the idea of like what it needs to contribute, what it needs to contribute more. Is there a risk that some project gets too much funding? Like, should I participate now? Should I participate later? And like people just sort of get a feel around all of these things, and the results that the mechanism provide just like seem better over time, right? Like you even get activities like people start like talking to each other about which projects are worthwhile. If some project is not worthwhile, then people complain about it, and so the culture around the mechanism develops, and like that actually does improve the results of quadratic funding over time. So we've learned a lot of interesting things, and I do think that blockchains are going to have an opportunity to kind of teach us many more things, to create much more room for experimentation. I'm particularly excited about blockchain scalability, just because that's going to create this opportunity where, because transaction fees are going to decrease by a huge amount, and so all of these things that people are talking about are going to be able to be done at just much greater scales. And I'm sure we'll learn a lot of interesting things from that as well, right? And so we're going to have more attempts at building currencies. We're going to have more attempts at building governance mechanisms, more attempts at building public goods funding mechanisms, more attempts at just building cryptographic security technologies of different kinds. And the crypto space is a very unique space where lots of these interesting things are happening. And I'm very happy about what it's done so far, and I'm excited about its future.